Question number 7 of the PhilNITS FE afternoon portion of the exam. We are now in sub-question 1. And in this question, we have to remember that we are talking about a heap data structure. Now, the heap data structure can be explained using this example where you got a tree like this. And of course, some of the examples that include also the array where we can do the heap sort. But for this particular portion of the sub-question, I think I was attempting to find out what the correct answer was for blank F, and I did get the incorrect answer, and so I wondered why it was the correct answer for this blank, which led me to answer letters D and E of the sub-question, because I was looking for the reason why the answer for letter F was a certain set of variables, or in this case, because it's supposed to have a 0 here, an integer. So I was answering this question and I ended up having to figure out what the answer was for D and E as well, because they're pretty much all connected to each other, and there are questions definitely that would be difficult to answer without answering the later ones. So in this case, because we have D and E here, we need to know what would be the correct answer to fill in the blanks. Now, heap down is something that we have to do after, for example, in this particular part of the code, after we've done a heap up, we need to do a heap down. And if we look at the description from the text, here are the user-defined functions. Heap up is supposed to recursively fix the heap, and the heap down is also supposed to recursively fix the heap. But in this case, for the heap down, we have to start from the parent. But in the heap up, it starts from the child. So there's a slight difference between those two. And I think I was also attempting to understand what those mean, which really led me to going to the function heap down. And in this case, we do have the inputs, the parameters. You got the data and the heap size, for example, how many elements are there, and the parent. Okay, I did also look at the portion where it explains what is happening in heap down. It says here, while the number of nodes in a heap is greater than 1, apply 1 through 4. And the pertinent portion of the text is this part here, where it says that if the parent node has less value than either of the child nodes has, you need to swap the root node with the child node with the greatest value. What that means is we need to know which among the children has the greater value, and we swap the parent node with that one. Only if the parent node has a lesser value than either of the children. So again, if the parent node, its value is less than any of the children, then we need to swap it with the children, particularly the child that has the greater value than the parent and the other child, because there are two children, okay? And then we recursively apply number 3, and that's how we fix the heap, okay? So if we go down to the actual code, we have here the function, and it says that there's a left child and a right child, and we get that by doing this computation using the parent index. Okay, and remember again, if we look at the array where it says here we need to fix the heap, if for example this is the parent, the child would be this one and this one. Okay, so that's why we have left and right child. And in this case, we assign first the left child to the child index here, which gives us the default value to be the left child, whatever index it has in the array. And then for the if statement, we need to know what should go in there. Now, if we look at the choices, we have here left child is greater than heap size, left child is greater than 0, left child equals to 0, left child is greater than heap size. And the answer, I think, was based, well, when I was doing it, I was basing it on the next if statement, where it says right child is less than heap size. And so I ended up also choosing letter A, because if the right child is less than heap size, then we need a way such that the left child will also have that same condition. Okay, and remember the heap size is the number of elements in the data. So I think in this case there should be 10 elements, and if the child is less than that, then it's okay, we get into the if statement. Now there are other choices like what we were reading a while ago too, but really if you got left and right there, and the right child is saying that the right child should be less than the heap size, for us to go into the part here where we have to give the index of the right child to the child, then I think the best answer for letter D would also be something related to less than heap size. Okay, and really what we're doing here is finding out which among the children has a greater value than the parent. Okay, so that's why the child would be later be used in the heap down function. Okay, and again the default in this case, if you look at this one, is the left child, but if the right child is greater, that's why we have this portion here, then the left child, then we need to assign the right child index to the child that we have here. Now once we've done that, we need to look into the next part, where if the parent is less than the child's value, the parent's value is less than the child's value, and we already have decided whether it's right or left, which children is it, and so we just get the value there and compare whether it's the parent's value is less than the child's value, and if it is, then we do a swap. Now for letter E, it would be good to remember also this one that we got from another portion of the code, where if we need to swap, we have to use the ampersand, this one here, this part, because in C, that means the C programming language, C++ programming language, that means that we are giving the address to the function. Okay, so what that means too is if we change anything in the value, then it's gonna be there. It's not just gonna revert back to whatever value it had before we put it in the function. It's gonna stay changed. Okay, so that part there where you got the ampersand is supposed to tell us that that's what it's gonna do, because again there are ways to pass variables without them changing after go out of the function. Okay, but again, I usually think about it in this way, um, just like what we do with the Java programming language. If you're gonna pass a value in a function and you change it, then it's gonna be changed. Okay, even if you go out of the function. Okay. Of course, if you have a variable inside the function that is not outside the function, then if you're not giving it out to the outer portion of the function, then I think if it changes there and you go out of the function, then it only changes in that part of the code, right? So that part about scope, is the value going to be changed if you pass it to a function and you go out? Is it still going to be the same previously before it went to the function, or when it goes out of the function, would it have changed? So that part I think is important that we understand, because sometimes you get people who get confused too. What is now the value of the variable? And in this case, by adding the ampersand, we're saying that if we swap it, then it's gonna remain swapped until we do something else with it. Okay, now therefore, if we have to choose among the choices, then what we're swapping again would be the parent and the child. Particularly in this case, the value of the parent and also the value of the child. Now we don't need to think about the left and right child or left and right children anymore, because we already decided which child it is. And so this one, and this one are all incorrect, and that gives us letter B as the remaining one, where we are uh, giving as input to the function the address, the reference address to the parent's value in the array, and also the child's value in the array. And if we swap them, then their values would be swapped as well. Okay, all right.